قابلنا التحدي في مدرسة الحسام، أسسنا منهج علمي يبقى لهم دليل، بنواجه الأزمات بتاعت ومش كلام، ونجيب لكل المشكلات حل وبديل، علشان إيماننا بربنا وحب في بلدنا، قدمنا ليكم علمنا علشان ولادنا، عهدك علينا مصرنا لما تعهدنا، توصل رسالة علمنا لكل جيل في مدارس الحسام.
Good morning, our dear students. Mr. Osama with you, teacher of chemistry. Let's continue our study about the chapter 4, which includes elements of S block and the B block. As we know before that, S block elements in group 1A, lithium, sodium, potassium, rubidium, cesium, and francium, that we have studied before. Let's continue our studies in the properties of these alkali metals in first group elements, group 1A. We have 10 properties here. We have studied already property number 1, 2, 3, 4, 5, and 6, reaching the reaction with oxygen. Let's continue property number 7, the reaction of alkali metals with hydrogen. The reaction of alkali metals with hydrogen producing hydride compound. As we know, the alkali metal has positive 1 valency. Lithium and sodium will react with a negative ion producing positive 1 ion. Also, we know before that hydrogen gas when reacts with other substance producing positive ion, except in this case hydrogen gas when reacts with alkali metals by heating, producing lithium hydride and sodium hydride. The hydride ion has a valency of negative ion. Here hydrogen carrying negative ions. This is exceptional case. Hydrides, they are ionic compound in which hydrogen atom has oxidation number -1. The hydride compounds has powerful reducing agent because lithium hydride reacts with water producing lithium hydroxide and hydrogen gas. Hydrogen gas make reduction to any substance that face it. So lithium hydride considered a reducing agent due to its production hydrogen gas. Property number 8, reaction of alkali metals with acid. This reaction is vigorous reaction, occurs very, very fast, producing heat. Like sodium metal reacts with HCl, aqueous solution, producing sodium chloride. This is simple substitution reaction as we know before in prep 3. Sodium chloride and hydrogen ion here produced, taking another hydrogen ion, forming hydrogen gas, evolved. During production of hydrogen gas, the reaction is exothermic, producing heat. The heat causes explosion and pop sound of hydrogen gas. Looks like a reaction of alkali metals with water. The same idea occurs here. Number 9, reaction of alkali metals with non-metal. We have 2 types of non-metal. Non-metals called halogens like chlorine, fluorine, bromine, iodine, and non-metals, non-halogen like sulfur and phosphorus. These are nonmetals but not halogens. Firstly, reaction of alkali metals with halogens producing salts, which is metal chloride or metal bromide. Like this reaction, sodium, 2 atoms of sodium reacts with 1 molecule of chlorine producing sodium chloride salt. Also potassium reacts with bromine producing potassium bromide. This reaction is a combination reaction. In the other side, sodium or potassium will react with sulfur or phosphorus nonmetal. Sodium combines with sulfur producing sodium sulfide. But this reaction needs heat to occur. Also potassium with phosphorus producing potassium phosphide salt also needs heat. Number 10, the action of heat on alkali metal oxygenated salts. Alkali metal oxygenated salts like metal carbonate or metal nitrate. All alkali metal carbonates don't decompose by heating, melted only because they are all stable except lithium carbonate. Lithium carbonate decomposes by heat at 1000 degrees, producing lithium oxide and carbon dioxide. So lithium carbonate decomposes by heating at 1000 degrees, producing lithium oxide plus carbon dioxide. Also alkali metal nitrate like sodium nitrate, as we studied before in Prep 3. Sodium nitrate, by heating, the thermal decomposition occurs producing sodium nitrite plus oxygen gas. If we replace sodium nitrate with potassium nitrate, the reaction will occur as it is in sodium nitrate, but in case of potassium nitrate, the explosion occurs, which is used in manufacture of bombs. Some bombs, in its manufacturing, we use potassium nitrate, which by heating results potassium nitrite and oxygen, and the explosion occurs. But sodium nitrate is a deliquescent material. Deliquescent material is a substance or material absorbs water vapor in the atmospheric air, producing semi-solid material. Extraction of alkali metals from their ores. As we know, ores means a natural product of the alkali metals in nature. As we know, alkali metals don't present in nature as pure substance, but they present as ores or as rocks. To extract the alkali metals from their ores, we can use this process, which is called electrolysis of molten sodium chloride. If we take sodium chloride salt, as we know sodium chloride is solid, make heating of this sodium chloride to produce molten substance. The molten sodium chloride here in this beaker make oxidation reduction reaction by using cathode and anode poles. Here cathode pole connected to the battery and the other side anode pole connected to the battery. The electron transfer through these poles producing oxidation reduction reaction. The sodium ion in the molten reduced gain electron to produce sodium metal, which is precipitated on the cathode pole. Also, chloride ion oxidized, losing electrons to produce chlorine, non-metal or pure chlorine in the anode pool, chlorine gas. And this reaction occurs. Chloride ion oxidation producing chlorine, pure chlorine gas, sodium ion reduction producing sodium metal or sodium solid. We will study two examples of alkali metals compounds. Example number 1, sodium hydroxide. Example number 2, sodium carbonate. Let's speak about sodium hydroxide. The physical properties of sodium hydroxide as follow. It is a white hygroscopic solid substance, and as we know that hygroscopic substance is a substance which absorbs water vapor from the atmospheric air. So sodium hydroxide solid, when exposed to the atmospheric air, they absorb, or the sodium hydroxide absorbs water vapor from the air, making semi-solid substance. Also, sodium hydroxide has soapy feel. Soapy feel, when you touch it with a little amount of water vapor, you feel a slippery touch or soapy feel, like a soup. But sodium hydroxide has a corrosive effect on skin, so take care. If we dissolve sodium hydroxide in water, forming an alkaline solution, the reaction is exothermic, liberate heat. If you put small amounts of sodium hydroxide in water, it will dissolve, liberating heat, which is called exothermic reaction. Also, sodium hydroxide reacts with acid. Sodium hydroxide reacts with acid like HCl or sulfuric acid, producing salt and water, and this reaction called neutralization reaction, as we knew before. Sodium hydroxide with HCl producing sodium chloride and water. Sodium hydroxide with sulfuric acid producing sodium sulfate and water. This reaction is a type of double substitution reaction, as we studied before in Prep 3. Sodium ion takes the non-metal ion and hydrogen ion with hydroxide ion forming water. This is called the neutralization reaction. The most important uses of sodium hydroxide used in many manufacturers like industries of soap, synthetic silk, and paper. The manufacturing of these products needs sodium hydroxide. Also, sodium hydroxide purifies petroleum from the acidic impurities. As we know, sodium hydroxide reacts with acids. So, if you put sodium hydroxide in petroleum products, the sodium hydroxide reacts with acids, producing salt and water, and make a purification to the petroleum products. Also, sodium hydroxide used in detection of basic radicals like cations, copper cation and aluminum cation. As we know, copper cation has a positive valency, positive 2, aluminum positive 3. Copper cation as an example of this cation in copper sulfate. If we put sodium hydroxide in copper sulfate, the reaction will occur as I will show you. Copper sulfate with sodium hydroxide producing sodium sulfate as a aqueous salt, and the copper hydroxide produced. Copper hydroxide is a precipitated, blue precipitate. A blue color precipitate of copper hydroxide. By heating this precipitate, the copper hydroxide decomposes, producing water and black copper oxide. So if we put sodium hydroxide in a salt solution and we obtain that copper hydroxide or a blue precipitate, this blue precipitate heated again, producing black precipitate So we conclude that this solution contains copper ion. We can conclude aluminium ion in any solution by using sodium hydroxide as follow. Aluminium chloride solution, for example, reacts with sodium hydroxide, producing sodium chloride and aluminium hydroxide by also double substitution reaction. Sodium takes chloride ion, aluminium takes hydroxide ion, producing aluminium hydroxide. Aluminium hydroxide is white gelatinous precipitate. White gelatinous precipitate. This white gelatinous precipitate reacts with excess sodium hydroxide, producing what's called sodium meta-aluminate. Sodium meta-aluminate is an aqueous solution dissolved in water. So again, we can detect the presence of aluminium ion by using sodium hydroxide. Sodium hydroxide take aluminium ion to form aluminium hydroxide white gelatinous precipitate. Excess of sodium hydroxide with this white gelatinous precipitate producing sodium meta-aluminate plus water, which is aqueous solution. The second example of alkali metals compounds, we will study sodium carbonate. Sodium carbonate is a white powder easily dissolved in water, producing alkaline solution. This is the first physical property. It is thermally stable compound. As we know before, that sodium carbonate, when heated, it melts without decomposition. It will be melt without decomposition. Melt as it is, sodium carbonate. There is no decomposition occurs by heating. Also, sodium carbonate reacts with acid like HCl, producing salt of sodium chloride, water, and carbon dioxide gas. Also, this reaction, we studied it at Prep 3 as an example of double substitution reaction. The most important uses of sodium carbonate. Sodium carbonate used in important industries as manufacture of glass, paper industry, and the textile industry. Also, sodium carbonate used in removing water hardness, water softening. We know that hard water contains large amounts of calcium chloride or calcium ions and magnesium ions. The hard water contains calcium ions and magnesium ions. We can purify the hard water from these ions, make softening of water through the following reaction. Firstly, we can prepare sodium carbonate by this reaction. Sodium hydroxide reacts with carbon dioxide by heating, producing sodium carbonate. This reaction occurs in two steps. Firstly, sodium hydroxide takes carbon dioxide gas and takes an amount of water molecules, producing washing soda. Washing soda, this name due to the effect of the sodium carbonate on water, which makes softening of water, converts hard water into soft water. That's why this compound is called washing soda. By heating this washing soda, it will decompose to sodium carbonate and 10 molecules of water vapor. Let's take how can we soften the water. Sodium carbonate Na2CO3 reacts with calcium ions in hard water, producing sodium chloride and calcium carbonate. Also, sodium carbonate reacts with magnesium sulfate Also, magnesium ion causes hardness of water, producing sodium sulfate and magnesium carbonate. This process used to purify or to convert water from hard water to soft water. Secondly, if we want to prepare sodium carbonate in industry, in industrial scale, there is another process to prepare sodium carbonate called solvase process. We cannot use the first process to prepare sodium carbonate because the first process is used in lab scale, in a small scale. Otherwise, the solvase process used in large scales as industrial scale. Solvay said that when we react ammonia gas, NH3, plus carbon dioxide gas, plus sodium chloride gas, plus water, liquid, sodium chloride aqueous solution, plus water liquid, this reaction producing sodium bicarbonate and ammonium chloride solutions. By heating sodium carbonate, it will decompose to sodium. Heating sodium bicarbonate, it will decomposes to sodium carbonate and water. Also, carbon dioxide evolved. Again, solvase process, ammonia gas plus carbon dioxide gas plus sodium chloride aqueous solution plus water. Sodium bicarbonate aqueous solution produced plus ammonium chloride. This sodium bicarbonate, when heated, it produces sodium carbonate aqueous solution plus water vapor plus carbon dioxide. Finally, we have to study the biochemical role of sodium and potassium ions. We have great importance of sodium and potassium ions in our body. Sodium ion, very important ion in plasma, in blood plasma, and intercellular fluids in the body. The role of sodium ion, the sodium ion has an important role in the vital process. The sodium ion represents the required medium to transfer the nutrients as glucose and amino acids in blood. Transference of glucose and amino acids from blood to the cells depend on sodium ion. Sodium ion occurred or present in vegetables, especially celery, milk and its products, milk, cheese, and so on, and yogurt. Potassium ions, from the common ions in the living organism, potassium also present in our cells, blood, and so on. The role of potassium ion, they play an important role in the oxidation of glucose in the living cell to produce the required energy for its activity. The burning of one molecule of glucose depends on potassium ions. Potassium ions needed information of ATP from glucose molecule. The source of potassium ions, the potassium ions present in vegetables, milk, meats, eggs, cereals. That's all we have today. Thank you for your listening and meet you in another session. Thank you very much. Goodbye.